Alright, so let's take a look at this problem, exponential decay. So it says a wooden artifact from an archaeological dig contains 60% of the carbon-14 that is present in living trees. How many years old is the artifact? And the half-life of carbon-14 is 1,730 years. Alright, so we'll use the function a of t is equal to a sub 0 e to the kt. Alright, so the main thing that we need to do is figure out what k is. Okay, now notice, I don't know if you watched the first example I did, but it's a little bit different than this one. They don't give us the initial amount in this one, do they? But that's not a big deal. Okay, so they tell us the half-life of carbon-14 is 1,730 years. So what that means is if we take the 1,730 and plug it in for t, okay, that's the half-life in years, that's equal to a sub 0 e to the 1,730 k. I'm plugging the t in, and that equals, okay, so what does it equal? It equals half of what we started with. Okay, that's half-life. In 1,730 years, half of what we started with is gone. Okay, well, how much did we start with? This amount right here. A sub 0, that's the amount you started with. So we have half of that left. Okay, so here we have an equation to solve. Well, let's write that down. A sub 0 e to the 1,730k equals 1/2 a sub 0. Well, look what happens here. Those cancel. So I'm left with E 1730k is equal to 1/2. See, what we're doing right now is we're using this information here that they gave us, the half-life of 1,730 years. We're using that to find k. Okay, we've got to know what k is. All right, so to solve this, I've got natural log e to the 1,730k equals natural log of 1/2. Okay, remember to solve this exponential equation, take the natural log of both sides. All right, so here I have, this is going to be 1,730k equals natural log of 1/2. All right, so remember this. I did it in the first video. I'll do it again in this one. The log of b to the x with base b. Remember, when these are the same, your answer is your exponent. Well, remember, natural log e to the power. Remember, natural log is the same thing as log base e. Okay, since these are the same, there's my answer. Okay, properties of logarithms. Alright, so now I'll divide both sides by the 1730. So I get k equals, and I'll need to punch this into my calculator. Okay, so there's k. Okay, and yes, there's more decimals. It's the rest of the decimals are 00663. And I would recommend, if you're working this, write all these out. I'm just going to do it to 4 decimal places for the video. Okay, so now we can take the k and we can plug it back in here to our function. Okay, for k. So I get a of t is equal to a sub 0 e to the negative 0.0004 t. Okay, so what do they want to know? They want to know a wooden artifact from an archaeological dig contains 60% of the carbon-14 that is present in living trees. Okay, so it's 60% of what's in living trees. Okay, so whenever the wooden artifact, whenever that died, okay, it had what was in a living tree, and then after it died, it started decaying, and there's only 60% of that left. Okay, so so they want to know how old is it. So we're looking for the time, how long it took. So a sub 0 e to the negative 0.0004 t is equal to, okay, how much is left? 60% of the initial amount. So that's 0.6 times a sub 0. Remember, a sub 0, that's the initial amount. So once again, the a sub zeros cancel, and we solve just like we did earlier. Well, let's go ahead and write this down again. Okay, that's a t. So I'm going to take natural log of both sides. Okay, and then once again, that's negative 0.0004 t equals natural log of 0.6. Divide both sides, and so I get t is, and I'll have to punch that into my calculator. Alright, so after I plug that into my calculator, okay, I get this number, and remember, that is in years. That's how many years it took it. And so that would be years. And so that would be my answer. Now, one thing we can do, does the answer make sense? Okay, so that's how many years that it takes for, well, there was 60% left. So that means after this many years here, 40% was gone. Okay, it was 40% was gone because it said 60% remaining. So 40% was gone. So look at that. That's 1,277 years for 40% to be gone. Well, that kind of makes sense because for 50% to be gone, you can see it takes a little bit longer, 1,730. Well, I say a little bit longer. What about almost around 500 years more? Okay, 1277 versus 1730. Okay, so it's, quite a bit longer. All right, so I hope this video helped. Check out my other videos, and don't forget to like and subscribe. Thanks for watching.